Hello everyone. So the next is continuous beams with sinking support. So we have already dealt with the supports which are in a straight line, that is the beam which are not sinking. And the next concept is continuous beam with sinking supports. So with this concept, now the theoretical part here is in a fixed beam, if RHS support, that is if the right hand support sinks or settles down, then the fixed end moments produced. Now, six fixed end moments produced is 6 EI delta by L square. And that is anti-clockwise. That means anti-clockwise means you're taking it as minus. So if the RHS sinks, if the with respect to left and right, suppose okay, now you can see here left and right. If RHS sinks, then MFAB is minus 6 EI delta by L square. So anti-clockwise means minus. So it is minus 6 EI delta by L square, where delta is the settlement, EI is the flexural rigidity, and L is the span. Similarly, if the LHS supports, left hand support yields or settles or sinks, then the fixed end moments, that is 6 EI delta, fixed end moment which should be applied to in order to adjust is plus 6 EI delta by L square. Rest of the analysis would be same. Okay, so what you're going to do here is in the previous type, that is in slope deflection equation, we are taken if the right side support sinks, then it is plus delta. If the left side support sinks, it is minus delta. Here also it is same, but here instead of in the slope deflection method, we used to take it as 3 delta by L. But what we are doing here is it is 6 EI delta by L square. We're taking this as a complete moment. Okay, let us take a problem here. So analyze the continuous beam by moment distribution method. If support B yields by 9 mm, take EI is 1 into 10 to the power 12 Newton mm square throughout. So EI is constant throughout, and draw the bending moment diagram. Okay. All right. Now you can see here what they have given is support B yields. So you can just draw this dotted line here. That means B is sinking. So it's sinking by 9 mm, and EI is 1 into 10 to the power 12 Newton mm square. Now because it is in Newton mm, you have to convert this into kilonewton meter, because all the values here in the given beam are in kilonewton. Load is in kilonewton and the distance is in meter. That's why I convert all the values into meter only. So that's why here it was delta 9 mm. So convert this 9 mm. So 9 divided by 1000. So it is 0.009 meter. Likewise, EI is 1 into 10 to the power 12 Newton per mm square. Okay. So now write this as it is. So it is 1 into 10 to the power 12. So now convert Newton to kilonewton. So from higher value, you're going to from a lower value, you're going to a higher value. So that's why it is 10 to the power minus 3. Okay, so now it becomes, from Newton, it becomes kilonewton. All right. So the next thing is you have to convert mm to meter, right? From mm to meter. Again, same thing. Mm to meter is 10 to the power minus 3. Okay, so it is 10 to the power minus 3. So mm becomes meter, but this is square. So that's why it is square. So I think this is EI is 1 into 10 to the power 12 Newton mm square. So it is not Newton per mm, it is Newton mm square. So that's why we have to keep this everything in the numerator only. Okay, so in that case, see here, so this is Newton to kilonewton 10 to the power minus 3, and this is mm to meter. So 10 to the power minus 3, the whole square. So this is 3 twos are 6. So it's minus 6 minus 3. Okay, so 12 minus 3 minus 6. So this would be 12 minus 9. So it is 10 to the power 3 Newton, kilonewton, meter square. Okay, so this is the EI value now, what we have to use. Okay, all right. So once you do all this calculation, next is come back to the problem. So you can see here again it is the same A, B, C, and D. So AB is loaded with eccentric support, BC is you having a UDL, and CD is having an overhang. So in AB, so as usual, you have to first find the fixed end moments. So all the necessary adjustments should be done in the fixed end moments only. Now B is sinking. So In AB span, B is sinking. So in AB, B is the RHS. So if RHS is sinking, so if RHS is going down, sinking by 9 mm, then the moment which is produced here is anticlockwise. So anticlockwise means negative. So it is minus. You have to make the adjustments here is minus 6EI delta by L square. Okay, now see here. First is MFAB. So MFAB is minus WAB square by L square. To this, you have to make the adjustment because it is sinking. That is, so right side is sinking. So right side is sinking means minus 6EI delta by L square. So first substitute the values WAB square by L square minus 6. EI you have already calculated. So it is 1 into 10 to the power 3. Okay. Then delta also we have calculated in terms of meter. So that's 0.0009 divided by L square. So L of this is 3 square. Okay. So substitute this, simplify this, and then you'll get minus 19.33 kilonewton meter. All right. Next, MFBA. So MFBA is WA square B by L square. Then again, same thing, because B is sinking here, don't write this as plus. It is still minus only. It is minus 6EI delta by L square. So again, substitute all the values here. So again, we have already calculated this here. Again, no need to write here. We have already calculated this here. So it is 6. So it is minus 6. So this is 20.67. Okay. Next, come back to BC. So in BC it is UDL, so it is minus WL square by 12. Okay, minus. So in span BC, so B is the left support now. So in BC, because B is the left support, and if the left hand support is sinking, if this is going down, okay, so in that case, you have to add plus 6EI delta. Okay, so you have to add plus 6EI delta by L square. So if you add this, so it is minus WL square by 12 plus 6EI. So it is 6EI delta by L square. Substitute these values here, 6 into delta, okay, by L square. All right. Then you'll get minus 60 plus 1.5. Okay, next. Similarly, CB. Again in CB, plus WL square by 12, plus WL square by 12, minus 6EI delta by L square. Sorry. Here also in CB. So B is sinking. B is sinking means left support is sinking. So left support is sinking means you have to add plus 6EI delta by L square. So same thing here. So it is plus here. Okay. So plus WL square by 12 plus 6EI delta by L square. So add this, then it is 61.5. Next, finally, MFCD. So in MFCD, it is now MFCD is equal to, because the first joint, so from left side if you see, it is minus. So it is minus 20 into 1. Okay, so minus 20 into 1 is 20 itself. So it's minus 20 kilonewton meter. So these are all the fixed end moments. So once you find the fixed end moments, next is again same as usual, distribution factor, moment distribution table, followed by the fixed end final end moments. So the only corrections for a sinking time in moment distribution table is you have to make these corrections here. There is 6EI delta by L square. Okay, next is distribution factor. Next is in BC, so joint B, BA, BC, joint C, CB, CD. Okay, again, stiffness in joint C is 0 because D is a free end and CD is a overhang support. Overhanging beam. So BA, okay, you can see here, BA 4EI by L because here it is fixed support. Whereas in BC, C is a simply support. So it is 3EI by L. Next, similarly, CB intermediate support. So it's a fixed support. So it's 4EI by L. And CD it is 0 because it's the overhang. Okay. So add all of these, then calculate the distribution factor for both of these. Okay. Again, when you add this, it should be equal to 1. Similarly here also. Okay, next is moment distribution table. Okay, so in moment distribution table, so it is first, write it as it is A, B, C, and D. Then member AB, BA, BC, CB, CD, DC. Then distribution factor. So for AB it is 0. For B, whatever we found out, right, 0.43, 0.73, 0.27, and the CB it is 1, CD it is 0. Here also it is 0. Okay, next, find and write all the values which you've calculated, fixed end moments, 19.33, 19.33, 20.67, minus 58.55, plus 61.5, and here it is minus 20, here it would be 0. Okay, now again, as usual, because it's a C is a simply support, so you have to balance the simply support first. So to balance the simply support first, so first take this joint. So 61.5 minus 20. 61.5 minus 20 is minus 41 plus 41.5. When you add this, it is plus. Now, after when you're writing in this balancing row, so the answer is plus, change the sign. So it is minus minus. So it is plus 41.5. Change the sign. So it becomes minus 41. Into 1 is 41.5, and this portion 41.5 into 0 is 0. Right? Okay. So now you have balanced joint C. Okay. So because you have balanced joint C, next is carryover moment. So joint CB from C. So from CB, it will be carried over to BC. So half of this, because again, why it is carried over to BC is because a joint B is an intermediate support and it will be treated like a fixed support only. So it gets distributed here, half of this. So it is now minus 20.75. All right. So now the next thing is, now only the carryover moment has happened. So next is you have to balance joint B. Now to balance joint B, so it is 20.67 minus 58.5 and then minus 20.75. Okay, so you have to take all the three, 1, 2, and 3, because all three exist in joint B. So once you take this joint B, so when you add all of these, so the answer is now minus 58.58 when you add all these three. So because it is a minus, now change the sign. So minus becomes plus. So just first thing is write this sign here, because later you tend to forget. So first thing is change the sign, write the answer, plus plus. Okay, next 58.58 into 58.58 into 0.73. Okay, 58.58 into 0.73. So it's 42.76. Next, this is again 58.58 into 0.27 is 15.82. Okay, so once you balance this, next is carryover. So from BA, it will get carry over to AB, because AB is the fixed support. So half of this gets carried over. So 42.76 into half of this is 21.38. The same thing if you try to do, you cannot balance, you cannot carry over at joint BC. That's because at C there is a simply support, and because we have made the simply support at this portion, that is simply support, we have already made it equal and opposite. We have made it 0 here. So you again cannot carry over this portion here. This moment cannot be carried over. It can be carried over only if there is a fixed support. So now because C is a simply support, so this step is skipped. So that's why now when you just try to check this out here, so in CD it is minus 20, you have marked it here, so it's minus 20. Likewise in this portion, so it is 61, that's CB, 61.5 minus 41.5. So when you add this, so it is plus 20. So this is plus 20 and this is minus 20. So both are equal and opposite, and this joint is balanced. Okay, so this portion is over. So next thing, any alteration should be done to the left side of this. So once you carry over this, so half of this is getting carried over, and once it is carried over, there is no other joint you can balance. So that's why this is the time here you need to stop. So again, finally calculate the final end moments. So the final end moments would be add all of these, that is at all AB columns. Okay, add all of these, and then this is 2.05. Next is at B and BC. So the check is at B, A and BC, that is cumulatively at joint B, it should be equal and opposite. The magnitude should be same, but it should be of a different signs. All right. So now, so it is first 63.43 positive, and here it is a minus 63.43. It's negative. So it's equal and opposite. So that's why whatever we have done is right. So this is like a final check. Okay, so once you find out this, next is just drawing the bending moment diagram. So first is drawing the free span bending moment. So in AB, BC, and CD. So in AB, it's a point load, so it is WAB by L. So it is 40 kilonewton meter. Next in BC, it is a UDL. So it is WL square by 8. So you're showing it WL square by 8, that is 90. And CD is a overhang. All right, so next is mark all of these. So this is A 2.05. So whether it's plus or minus, always you have to mark it here. 2.05. Next here it is 63.43. At B it is same. Then at C it is same here. That is equal and opposite. And at D it is 0. Okay. So mark all of this. Join all of these points. So whatever lies below, okay, exactly on the support would be a negative bending moment. And you can see that will be at A, B, and C, and a D it's 0 because it's an overhang, and joint D is a free end, and whatever lies outside this becomes a positive bending moment, which is hatched here, that is plus. Okay, so this all a positive bending moment, these are all the negative bending moment. All right, okay, that's all for today. Thank you.